In this video, we'll explore scientific notation. Now, what is scientific notation? Scientific notation is just a way we can represent numbers that are very large or very small, and something so that we don't have to look at the number as if it crosses the entire page. It's a way to make it more compact and easier to read and recognize. Our calculators already have to do this because they have a limited screen size. So whenever you see this capital E raised to some integer, that's the calculator taking the value that is the final solution and putting in scientific notation because it doesn't have enough places that it can put on the calculator screen from left to right. Now, when we define scientific notation, we say that it is a times 10 raised to the nth power. That a value has to be a number between 1 and 10. It can be 1, but it must be less than 10. The n value has to be an integer. Those are positive and negative counting numbers like 4, 6, negative 10, negative 15, not 3 and 25 hundredths. No decimals in that n value. It has to be an integer. So let's look at some examples real quick. So we want to determine, is it in scientific notation? If I look here, this number 9 and 42 hundredths is between 1 and 10, and it's raised to an integer, so yes. Here, 13 and 7 tenths, that's greater than 10, so no, that's not scientific notation. The negative 8 is perfectly fine. Here, 56 hundredths, that's less than 1, so no, that's not scientific notation. But the 6 is okay. Here, 3 and 2 tenths, that's between 1 and 10, and negative 5 is an integer, so I'm good. Here, 4, it has no decimal, but that's okay. It's between 1 and 10. So yes, this is scientific notation. And our last one here, 123 and 2 tenths, that's way over 10, so that would not be scientific notation. Although the negative 15 is okay for an integer. So let's look at how to convert to scientific notation. We start with our number in decimal notation. We then identify the decimal. Now sometimes there may not be a decimal, and that's okay. We know it's always after the ones place. To create the a value in scientific notation, we're going to move that decimal until it creates a number between 1 and 10 with what we have. For our n value in scientific notation, we're going to count those number of moves. If we had to move to the left, that's a positive n because that was a number greater than 10. If we move to the right, that's a negative n because that created a decimal less than 1. Let's look at an example. So say I have 923,457 and I want to convert that to scientific notation. First thing I do is I write out my number. Here's 923,457. I remove my commas because it's easier. Now, what I don't have here is the decimal. The decimal is after the ones, so it's going to go right after my 7 right here. Now I'm going to count as I move to create my number for A. So that's 1, 2, 3, 4, 5 moves to the left. So my n would be a positive 5. So my a value, 9 and 23,457 hundred thousandths, my n value, positive 5. I put them together for scientific notation, and here I have 9 and 23,457 times 10 to the 5th. It's the same number, just written in scientific notation. Now what if I wanted to convert 367 hundred thousandths to scientific notation? First thing I would do is write out my number with my decimal place there, and now I would go through and actually move it until I represent a number greater than 1. So here I have to move my decimal to the right 1, 2, 3 times. Now I have a number in the ones place, so I can say I moved my decimal 3 times, but it had to go to the right because my number was less than 1, so my n value is negative 3. So I can now say that it's 3 and 67 hundredths times 10 to the negative 3rd. Now what if I want to go the other way and convert to decimal notation? What I would do is I'd write out my a, and then I would move my decimal n times. If it is a positive n, I now shift that decimal back to the right. If it's a negative n, I shift it back to the left. And think about why. A negative n means my number is less than 1. A positive n means my number is greater than 10. So I want to make sure my numbers are matching correctly. You will likely have to add zeros to your decimal notation as you go along. So make sure you're paying attention as you count. If there's not a number or if there's no digit there, you're going to have to put a 0. So say we have 2 and 75 thousandths times 10 to the 7th, and we want to convert that to decimal notation. So I first write my number 2 and 75 thousandths. Now I'm going to move my decimal. I'm going to move it 7 to the right. 1, 2, 3. Now as I move to the 4th, I have to put a 0. Move to the 5th, put another 0. Move to the 6th, another 0. And 7th, put a final 0. Now I can look and say, okay, go back, put in my commas to make it a little bit easier to read, and what I have is 20,750,000. What if I had 3 and 1/1000th times 10 to the negative 5? Here, I move my decimal to the left because my number, by being a negative exponent, is going to be smaller than 1. So I move it 1 to the left. And I'm adding those zeros as I go along. I need to move 2, 3, 4, and 5. Now you'll notice I always put that extra 0 in the ones place because I find it easier to read the number. So here I put in my decimal. So now I have 0, and then I've got 4 zeros after the decimal, and then the number 3001. So here I have it written out. It's very small, and that's okay. Now say we need to compare numbers, and some are in one notation and some are in another notation. If you're going to do that, just change both to the same notation, whether that's scientific or decimal. For example, I want to say which is greater, 90,456 or 9 and 7500ths times 10 to the 3rd. So I can choose which would I rather change. Maybe in this case, I'd rather convert the 9 and 7500ths. So I move that decimal 3 places to the right, and that's going to give me the number 9,750. Now I'm really comparing 90,000 to 9,000. I know that the 90,456 is greater than 9,750. Well, you could also be asked to actually sort your numbers from least to greatest or greatest to least, and there's a mix of what's going on here. So I need to convert them all to one form or another. Maybe in this case, I'm going to convert them all to scientific notation. That 81 thousandths would represent 8 and 1/10 times 10 to the negative 2. And then the 10,005 100,000ths would represent 1 and 5 10,000ths times 10 to the negative 1. So now I have all my numbers in scientific notation, and I know that the greater the negative exponent, the smaller that number. So here I see that I have two that have a negative 3. And I say, well, which is smaller, 1 and 8/10 or 2 and 3/10? In this case, 1 and 8/10 is smaller. Then I'd say, okay, the negative 3 is smaller than negative 2, so 2 and 3/10 times 10 to the negative 3rd would be next. Now, negative 2 is going to make a number smaller than negative 1, so the 81 thousandths would be the next in line, and then finally, I would have the 10,500 thousandths.